Imagine you write a function in C to swap the first and last numbers in an integer array. It works perfectly. But now you need to do the same for an array of floating point numbers, and then for an array of strings. You find yourself writing the exact same logic over and over, just changing the data type. This is the rigid world of static typing, and it begs for a more elegant, universal solution. The obvious first step is C's generic pointer, the void point, a pointer to, well, anything. You rewrite your function to accept a void pointer array. Problem solved? Not quite. When you try to find the last element using pointer arithmetic, the compiler stops you cold. It knows the address of the array's start, but because it's a void point, it has no idea how many bytes to jump to get from one element to the next.
Is an element 4 bytes, like an integer, or 8, like a pointer to a string? Without knowing the type, the pointer is just an address with no sense of scale. The fix is a classic C-style maneuver, a direct manipulation of memory. You passed in the element size manually as a separate argument. Then, to perform the arithmetic, you cast the void pointer to a char pointer, a pointer to a single byte. Now, adding, say, 12 to the pointer moves it forward by exactly 12 bytes. You're no longer thinking in terms of integers or floats. You're thinking in raw bytes, manually calculating the offset to any element in the array. This gives you a truly generic function that can swap the ends of any array. But this only solves generic data. What about generic behavior? Think about sorting an array. The core logic of a bubble sort is always the same: iterate, compare, and swap. But the comparison itself changes. Do you want ascending order, descending order, by absolute value? A single sort function can't anticipate every possible rule. The solution is to make the comparison logic itself a parameter. You pass in a function pointer, a variable that holds the memory address of a comparison function. Your generic sort function runs its loops, but when it needs to decide if two elements are out of order, it doesn't use a hard-coded greater than or less than symbol. Instead, it calls the function provided by the user to get the answer. This is the principle behind C's standard library QSort function. It combines both techniques. It uses void point to work with any data and a function pointer to use any comparison rule. It's the ultimate separation of concerns. The algorithm provides the method, and the caller provides the meaning.